Awesome. So we're trying another new setup tonight. So I'm trying to screen share from the other computer. I figured out at work that like whatever screen sharing video conference thing I do, it just like chews up all of my resources. That and like trying to demo code or trying to like demo an app. It's like crazy. So anyways, we're trying both computers tonight and see how that goes. So super cool topic tonight. I am really excited to dive into it. S.O.L.I.D principles. This is like a high risk presentation for me. This is like I don't feel like a lot of people will like do like webinars on S.O.L.I.D or really like any of the OOP principles. So like I'm really like I'm gonna bite off on something crazy at the end of the year, Rach, and like ask Peyton. I've put this off pretty much until the last minute, but I prepped, and this is gonna be awesome. I'm pretty excited to talk about this. So. Okay, before I do that, just a quick primer for those listening to the recording. My name is Scott. My co-host is Rachel. We are married. Rachel, let's start with Rachel. Rachel is a tech recruiter at a company called GoodTime.io. She has been in the tech space for quite some time. Together, we worked on Prime Kansas City. My history goes back further with Prime. I was the first employee, which is a bootcamp PS. Currently, though, I am working at Nerdery as a principal software engineer, and I've got some hella cool announcements around that job in the beginning of the year. So I'm working on some stuff that I'm pretty excited about. More on that to come. Okay, so Aftercamp, what Aftercamp is it was an idea that Rachel and I had. We have been working in that 0 to junior space for a number of years. It feels like a long time. And really what we've been obsessed with is this junior to mid to senior space. So what we did is we started collecting ideas of things we wanted to cover that would be beneficial to somebody's career post-graduation from a boot camp. So the other thing we knew we wanted to do too was cover topics that aren't really well represented. So it'd be really easy to get on here and do a React tutorial, but there are a billion React tutorials. And then just a quick note too, make sure you mute yourself. Hang on, I'm gonna mute people. Okay. Yep, cool. But yeah, the focus was really to cover a number of topics that were not well represented out there in the community. So the topic of tonight is the S.O.L.I.D principles, which is if you've applied for jobs, I am sure that you've seen something to the effect of OOP principles, S.O.L.I.D principles, something to that effect. So the idea tonight is to contextualize those for you. And so some of this is going to get weird, just as a heads up. This is a tricky topic because most folks here got into programming through JavaScript. So most folks, not all folks, but most folks. And so, and then most folks, once again, I'm speaking in generalities here, went through some sort of boot camp. So your entry point to programming typically is something to the effect, you've probably started with HTML and CSS, moved to JavaScript, moved to something like jQuery, got into Node, got into like Postgres or Mongo, came back and did React. And that's kind of been your flow into the development world. And inversely, if you are coming at this from like a CS degree, you actually might be very familiar with S.O.L.I.D principles. In fact, you probably aren't even on this call because you do have a good background, maybe not. And so my idea is to kind of marry the two tonight. And really what makes this topic so tricky to talk about is that if you're coming in at the first way that I talked about, really through JavaScript, there are a couple things that may or may not be foreign to you. Things like TypeScript. We're going to use TypeScript tonight, almost actually exclusively, a little bit of JavaScript. And so there's this idea of TypeScript that we kind of need to chat about. There's these ideas of OOP or object-oriented programming that we need to layer in. And then like S.O.L.I.D kind of comes next. And so in order to get S.O.L.I.D well, and maybe come back to this talk later or watch this again, you definitely want to understand TypeScript and like static typing and what that does, have a good idea of OOP, and then kind of scaffold into S.O.L.I.D. Now, to be clear, if you don't have those things, you're not at a loss tonight. I do think that tonight will still be a good kind of primer on S.O.L.I.D and why things the way they are. And this is like a weirdly important topic because so much of what is out there in terms of frameworks, if you like go into the framework, you actually end up seeing a lot of frameworks utilize some of these patterns and some of these principles. And so the other side of this too is that when you look at what I would consider to be great architecture for React or Angular or Node even, they actually utilize a lot of these principles as well. And so there is a life beyond the architectures that you learned at somewhere like Prime or any of the other boot camps that are out there. And they get significantly more advanced, but there's this very important reason why. And I think early in my career, I had said, screw that. I know how to get it on the screen. People can click on it. It's good to go. And, you know, like 10 years later, I'm still right. I still like feel like that's a pretty good, like, yeah, like at the end of the day, your job is to make interactive experiences for your users that kick ass. And maybe what's under the hood doesn't matter as much. But I'll tell you, having clean architectures that your team understands really kicks ass. And I always use this metaphor at work. I'm like, if we can raise the floor of our understanding as a development team, things get faster, more secure, scalable, all those things. So my current role right now as a principal software engineer for Nerdery, I mostly kind of just like, and you can ask Peyton this, but I mostly just roam the halls and play architect. They don't let me code as much anymore, but it's kind of like helping establish like the system architecture. I kind of want to go through this real quick. So like I see like software built in 4 levels. The first is where we all started, like when you learn programming. Yeah, sounds like a Scott problem, present Scott problem. The first level is like syntactical architecture. So like, how do you write a good line of code? Like that's a really interesting question. So it's syntactical. And like when you're thinking about first programming, you're kind of learning line by line what the code does. And eventually combine those lines to make up the second layer. And this is like the 4-letter word for most programmers, and that is the algorithmic structure or the algorithmic architecture. Like algorithms, like actually by definition, like almost everything's an algorithm that you write. If you write a function, you wrote an algorithm, you wrote a series of instructions. But typically when we hear the word algorithm, we think the elegant performance solution. And so there's an architecture to those algorithms. Go up a level from there. So we have syntax, algorithmic, then we go up another layer and we get into software architecture. And when this is when we start thinking about like, how does the piece of software work? And for the most part, if you learn full stack, you actually are primarily working in 2 pieces of software, the client and the server. We don't often think about it that way because there's such not like a tight coupling, not the tight coupling in the sense of like what tight coupling actually means in programming, but like the client doesn't really do anything without the server. The server is there for the client. Like they're built for each other. They're made for each other. And then at the 4th level, this higher level, we have the system architecture. And what a system is it's a grouping of softwares that talk to each other to accomplish a thing. And so typically when you're at bootcamp, you learn, you really focus on software architecture, but there is like little hints of system architecture and algorithmic architecture in there as well too. So, and then you kind of branch off of that, right? Like you go get a new job, and ideally, or like one of the problems I see in the industry is that most hiring managers don't think that way in terms of those 4 layers that I just laid out. So they start at the bottom and they're like, when they assess you and like, they do like a code challenge. They're typically assessing you either at the syntactical layer or the algorithmic layer, but really your center of gravity is in that software layer, and and maybe into some extent that system layer. So how does this have to do with S.O.L.I.D? Well, when you've done, oh God, I'm gonna make myself sound old, Peyton. He's gonna make fun of me. When you've been doing this for as long as I have, which is over 10 years at this point, I started in Flash. And Flash, like really, like we can rag on Flash all you want, but ActionScript as a language is actually pretty damn mature. And so I got a chance to see a lot of these patterns back in ActionScript days, because we didn't like use Flash Professional, we used Flash Builder. And so like we literally built software from the ground up, was really cool. And then Flash got killed, and then JavaScript came. And when we first started writing JavaScript with jQuery primarily, we actually were having to kind of home roll everything. And so these patterns really started to live on. And now things like React and Angular make everything so damn turnkey that you like the focus on these things aren't as prevalent. And the thing that I'm noticing, that the reason why I think this is such an important topic is because another wave is going to come. Like I hate to spoil this for you. If you're in like the 5 years, within 5 years of starting your career, like you might have not gotten to this next wave of your career where something new comes along. And yes, JavaScript, I get it. Like new things pop up every day, but like something like foundationally that changes, like crazy changes the foundation of everything you need to know. And so what I've noticed is that all of these different things I've written in end up following these same damn patterns. And so they're really, really good to learn. And so I got a variety of examples tonight. We're gonna cover S.O.L.I.D, go through it all, and really introduce you tonight, and then hopefully get you thinking about it as you progress through your career. So let's start off with what is S.O.L.I.D. And so S.O.L.I.D is an acronym. And so S.O.L.I.D represents 5 pieces. This single responsibility pattern, the open-close principle, the Liskov substitution principle, the interface segregation principle, and the dependency inversion principle, not to be confused with dependency injection. Those two things are actually two different. It's a good topic to read about. So we're just going to go through all 5. And I got kind of a smorgasbord of examples here. I contextualize, of course, everything in TypeScript, Node, TypeScript and Node where I need to, otherwise just like TypeScript. And so I guess we just hop right in, right? Let's just get in there and start chatting about it. So we're gonna go right down the list. We're gonna start with S. We're gonna start with the single responsibility principle. So you should be able to see my screen. I think we're good to go. Just pulling chat back up so I can see everything. Okay, hopefully that works. Okay, so single responsibility pattern says this: a class or function should have exactly one job. And I was thinking a lot about this. There's like tons of different examples out there. And I think like intuitively you might get this. Intuitively you might be like, well, whenever you like create a huge function, I'm sure your instructors or wherever you're learning said, well, if you're building massive functions, you should really start to break things out into other functions. And the reason for that was, of course, reusability. Of course, don't repeat yourself, dry, which is a dry principle. So basically, there's this idea of reuse. And if you can abstract your functions and your methods to a point where you can reuse them, that's a good thing. But also, too, it also like helps out quite a bit. Yeah, testable for sure, too. And actually, that's a big topic tonight, too, is being able to test things. So breaking apart good things. But really, when you start to establish your place, in the full stack world, you start to like look at something like Node. And if you look at a Node tutorial, most Node tutorials follow the same pattern. And the tutorials that are out there are typically trying to teach you like, oh, here's how you build a RESTful API. They're not really trying to teach you how to build solid applications. So I have a kind of a classic example here of what you typically see. So here is some JavaScript. And what we have here is a router that has a post endpoint to register. And what we're doing here is we're registering a new user. So we would do something like where we would take the entered username and email off the request, and we'd store it into an object. We would do something like encrypt a password. So we take their password, add a salt hash and perhaps a pepper. And then what we do is we'd insert this into the database. And so we structure our query here. This, of course, is not using an ORM. And then we would say, hey, database connection, let's go ahead and jam that query into this. And this is like the perfect place to really start pointing out single responsibility pattern, our principle. And so the problem here is that this route is doing a ton. So let's just ask the question for a minute. Like, is registration the only time that we would create a user in our system? And the answer might be yes. Like the only way you might be able to like create a user is through this front end user interface that calls an API to whack register, and they create an account. But what if you are also creating an admin panel that you're able to create users there as well too? And then you might say something like, well, we can access that same API route to register a new user. And what's happening is you are letting the UI determine exactly how this application is going to work. Because I think that the way that some people would approach this, we would say something to the effect of like, well, I have the register route ready. So for the admin view, what I'm going to do is I'm going to build a create user page from the admin view. And I'll make sure to add in a username and password that I'll give to this route. And this route will go ahead and crank out a new user, etc. And that may be a good solution. But once again, we have the UI dictating the way that the rest of the application should work. It's kind of a crappy thing to do. So the idea is that we actually want to start to separate what we can call the controller logic. And this is a controller, to be clear. And it's a controller because it handles the route and then has essentially logic to eventually create a user. And the idea is that we have a controller that is also accessing the data persistence. So here we are saying, let's go ahead and pull in the pool. Let's go ahead and jam in that query. And really, I think this is a perfect example in modern times where we want to actually split these things apart. So what I'm going to show you is, if you have never heard of Express Generator, Express Generator is a module that you can install globally and with NPM, and it'll basically scaffold an Express application for you. And they have a TypeScript version of this. And so you can get Express Generator TypeScript. And so what you're about to see is code generated from Express Generator TypeScript. And it's actually, it was interesting when I pulled it up because I was hoping that they would do this. But before I get into the code, let's actually just go through. Actually, I'm going to get into the code, but before I get to my end place, let's go ahead and start at the index. So typical stuff you would see, go ahead and create a server, go ahead and connect to a port, listen on that port. And then the server is in TypeScript. So it's in, this is kind of a cool, like if you want to get more and more into TypeScript, this is a great way to, great example project to look at. So they're doing some crazy stuff. Maybe you've worked with Cookie Parser, maybe you worked with Morgan, Path Helmet, all these things. You definitely have worked with Express before. HTTP status codes is cool. And so there's some good stuff in here. And you know, you'd be like, okay, well, I see this. I recognize this line. This says if the client side wants to access the API route, we're going to send them to the base router. So we go over to the base router, and then we also see something semi-familiar. Now we're routing to the route, right? We are, you might have not seen this pattern before. There's a lot of different ways to cut Express, but for the most part, you probably get it. We have a router that we're creating on the back ends, and we're calling it user router. And we could set the get, post, put, delete here. And what we're doing is we're saying, just like we would if we were spinning up beginner Express, we say, here's the route. And then we typically point to some sort of callback function. So it looks something like this. If we were doing this by hand, we'd say user router.get API cats. And then I would probably say something like, you know, you could do function, but we're using ES6. So we say, something like that. And so we would go ahead and build out our route. What they're doing here is instead of actually using an anonymous function, they're using a declared function. So let's go over and take a look at the declared functions. Specifically, we want to look at add one user. Close this out, don't save that. And so we end up eventually at this user route. And so here you'd expect to see the request and response coming in. That probably looks familiar. Add one user looks, you know, this is what we're calling the function. We're going to go ahead and add a user to the database. And then the rest kind of looks, you know, it ends the way that you would think it would. It returns a response to the front end. But then we get into this part here, and this part's a little weird. We say, okay, well, we're stripping off the user information off the request body. If there's not a user, we're just sending back, hey, error. We can actually just delete that for now and make it simpler to look at. So then we come across this line. We say await user DAO or DAO. So this is what's referred to as a data access object. And what a DAO does is essentially it is the class that basically is abstracted away from the controller, because that's what we're looking at right now. We're looking at a controller, and we're taking the data persistence out of the equation and putting it into a different class. So here we're saying, okay, there's this user DAO, and we have an add function or add method, and it accepts the user that we're passing in. So here what we're saying in this user DAO or this class is we are going to have this add functionality, And this is where we would actually do something like go ahead and add in the query, right? We'd actually do the data persistence here rather than in the controller. And let's go back to the S. S is the single responsibility pattern. A class or function should have one job. Well, before, the controller had two. It had to be the controller, like the business logic, and then it had to be the data persistence layer. It had two jobs. And I think that's a very common pattern that most people see. But now what we want to do is we want to separate them. And the answer or the question might be why? Well, going back to the scenario that we set up earlier, we had said, well, the user can create themselves an account, but what if we want the admin to create an account as well too? Now all I need is two controllers, but I have one DAO, right? So I have one controller that we can access as that API endpoint if we want to, or we could have a different API lead to the same function because the function is extracted too. And so then we could basically say, okay, two API endpoints point to the same controller that point to the same DAO, but everything is separated out. So I get to pick as a developer when to call that stuff. As a developer, I get to pick when I want to use that controller. I get to pick when I want to use that DAO. And so that's what single responsibility principle is all about. It's the separation. You might have heard this like a separation of concerns, but is the separation of classes and functions to have one responsibility. And I think a great way to get into this is just playing with the Express Generator TypeScript module and actually just setting up a baseline project and just poking through and seeing how they have it set it up and seeing if you can understand it. So a good next step would be start this up, follow the patterns and see if you can see how they have their architecture set up. And then on top of that, actually try to plug in like a Mongo or a Postgres and see if you can get like something to save. That would be a really cool challenge or a really cool project for you to work on. So things are separated. That is what S is all about. Okay, I'm going to go to the next one. Much lighter example. And I pulled these examples from a couple of different articles. And so I will share those articles, and some are homemade, but this one I thought we're coming out of a heavy topic. Let's go to an easy, fun topic. So I got superheroes, Thor. This is pulled. This is not me. This is somebody else, but it's a good example. So the O is and I understand it from Minnesota. So like my O's are weird. The O is open close principle. And basically this says that software entities, so classes, modules, or functions, should be open for extension, but not modification. Now, this plays off another set of OOP concepts that are really important, right? There's the classic four. Does anybody know the classic four OOP principles? I'll give you guys a second to see if you can get it. If anyone wants to show off. It's like, shut up, Scott. I don't remember that stuff. Google. Okay. So we have inheritance. We have encapsulation. We have polymorphism. Does anyone know the last one? Abstraction. There you go. Cool. So this one plays off polymorphism. So let's set up a very basic, we have a very basic class example here. So first off, class, we have the constructor, which all classes get. It's the functionality that runs when you create an instance. When we create a superhero, this is the code that runs. Then we have a method on that class that basically says, well, if we were to go ahead and create const super Scott equals a new superhero. Oh, come on. Superhero. We could go ahead and then say super Scott dot get weapons. So this function here is available to me because I've created it inside the class. And when a function is inside of a class, it's no longer called a function, it's called a method. So what this principle has everything to do with is really the functionality. And so so here we're going to talk about polymorphism and one more, and that's inheritance. So here we have Thor extends the superhero class. And so basically what we're doing is we're copying the blueprints for a superhero, and then we are adding on or changing that blueprint. So if we said const Thor Scott equals new Thor, we still get the ability to add in a name. So really quick, how that works is I'm creating a new Thor, and I'm able to pass in the name because Thor extends off of superhero, which has that constructor that takes in the name. So Thor is inheriting the constructor in its other methods because it is because of inheritance. Okay. So then where does polymorphism in this principle come into play? Polymorphism, and it's less prevalent, I would say, in JavaScript and TypeScript, but polymorphism says, or is the idea that we are going to change the functionality that the base class gives us. So here what we're doing is we're saying get weapons on the superhero base class does nothing. But when I create the Thor class to extend the superhero class, I'm taking the get weapons method and I'm changing it. I'm basically saying, I'm going to take what it was doing before, which happens to be nothing, and I'm going to redeclare what it can do. So here I'm going to say, well, Thor gets the weapon Stormbreaker or Mjolnir, or depending on whatever you watch the series. So we're basically changing, we are using polymorphism to change what get weapons does specifically for the Thor class. Same with Captain America gets a shield, Iron Man gets the suit. Now, the trick here in this open close principle is that we are modifying the essentially through polymorphism, we are modifying the base class, but we are intentionally not going to change the base class to fit our scenario. So the idea behind this is, and this is like the classic how this happens. So this would be like the typical case, right? Where I'm going to say, okay, well, I have a superhero, and the first superhero I'm going to make is going to be Thor. Well, I know that Thor is going to be Stormbreaker, so I'm going to say return Stormbreaker, and I'm like, great. So then I say, okay, I want to create a Thor. I'm going to set this to a new superhero, and I'm going to call it Thor, like so. And now my awesome new Thor superhero can get Stormbreaker. And I'm like, okay, cool. Well, now I want to make an Iron Man, and I'll create a new superhero. And I'm going to say, okay, I want to make Iron Man. And then I go to get Iron Man's weapon. And I'm like, oh shit. The only thing that Iron Man can get right now is Stormbreaker. So then I might do something crazy where I'm like, well, okay, I'm going to do an if this dot name equals Thor, and then I will return Stormbreaker. And you're like, oh crap, I got to make a name. And else if you're like, Scott, this is painful. I'm like, I know, trust me. Iron Man, return suit. So we might go down like some path like this. This is a bad path to go down. This is really like, this is supposed to be like just generic. This shouldn't have like these implementation details in it. Like, I don't really care. This, like, the superhero class does not need to be the heavy lifter. Instead, what I want to do is I actually just want to go ahead and say, well, you know what? We are going to have get weapons. Will be a piece of functionality. And then I'm just going to undo this until I get back to where I was. But then what we're going to do is we're going to go ahead and through polymorphism and the open close principle, we're going to inherit from superhero. We are going to make this class polymorphic in that we're going to change the functionality of get weapons. And then we're going to honor open close principle by not touching the damn parent class. So we aren't touching this, but we can go ahead and make modifications in those subclasses. Pause for a second. It's spelled Mimi, right? I don't know. I can't spell. Great question. Why leave the method in the parent class? So this gets into like a lot of why have interfaces and why use TypeScript? Why why use strongly and statically typed languages? And the answer is it's a little bit of like pick your poison, right? I think that in some ways, and actually I just released a course where it's a 5-hour course on like kind of the introduction to web development concepts and ideas. And in that I talk about static versus dynamic and strongly versus weakly type languages. And the case I make for strong languages is you're picking to basically have your errors up front and your planning done up front. So the reason why we would do things like forward declarations of like methods, or we create things like interfaces or abstract classes, is it's all about planning. And when you plan, you can actually, like, as you get further down the road, and you'll see this in another principle here in a second, we can plan and we can protect. And then eventually, as Peyton mentioned, we can test, which ultimately at the end of the day still leads to software, just the way that JavaScript in its weakly dynamic state would get you software. But all your debugging would be on the back end. You wouldn't find out till later that you made a mistake, where when you use something that's strong, static, and so on, using interfaces, using abstract classes, you can start to see where the cracks actually are. Furthermore, when you're working with 30 developers on a team and you're creating a piece of functionality, you're like, please, for the love of God, don't use my class unless you're giving me this, because my class isn't built to handle anything. It's built to handle this one thing. Because trust me, if you build it and somebody sees it, they'll try to use it in a way that you didn't intend to. It always happens. So code maintenance. Yeah. So I'll tell you what, who asked that question? Ronald, if I don't hit that by the end, if you don't have a good solid understanding that, we'll circle back on that. Let's get into L. This is the Liskov Substitution Principle. And what she was all about, what she wrote, Liskov, she said that a subclass must be substitutable for its parent or superclass. So similar kind of situation here. I have good and bad examples here. So here we're starting off with bad example, a little bit contrived, but let's just say we have a restaurant employee and they have an empty constructor. It's fine. It's the constructor is not important for this, but there's two methods. There's clock in and clock out, and I only include two just because I just want to show you that we can expand these as far as we want, but the focus is going to be this clock in. So here we have inheritance happening. We say, okay, well, I have a restaurant employee and I'm gonna create a new class called host employee, and it's gonna extend off the restaurant employee class. So it gets all of this functionality. Then I decide to be polymorphic in changing the class to add in a new piece of functionality. And this one, it says clock in host. And you're like, well, why didn't you use clock in instead? And I'm gonna get to that. So here we have clock in host, and it returns host checked in or host clocked in. Same is true for cook. Same is true for delivery employee. I'm feeling pretty good because I wrote a lot of code and I wrote a lot of custom scenarios. I'm feeling pretty kick-ass about this. But when you think about it, if I needed to have an array of employees like here, so here we're using some JavaScript notation. I'm going to explain this in just a sec here. So we're saying array. We're using something called a generic. Generics exist in other languages. So it's definitely a nice addition to TypeScript and the JavaScript ecosystem. But what I'm saying here is I have an array of restaurant employee and any other class that inherited from restaurant employee. So now what I have is a situation where every employee I create is going to end up in this array that we're passing to this clock in everyone piece of functionality. So this functionality says clock in everyone. And the idea is that we take all the employees in as an array and we pass that array in. Then I use a for loop to go through that array. And what I want to do, or my intention is to clock everybody in. Well, what I did is I made these special modifications. I said that we're going to basically make these custom login solutions. So here's the problem. Is that Liskov says that any subclass should be interchangeable with its parent class. And this is why, is because here I want to have the ability to have a multitude of different types of employees. So I say I want to create an array of only restaurant employees or their child classes, because what I want to do is I want to guarantee myself the functionality that they took the clock in base functionality and implemented it in some way in the class. A lot of different ways to do this. I'm just using this particular way. And the reason is because I want to guarantee that clock in is a piece of functionality that works when I go to run something like this. Now, the real pain in the ass in this example is that not only will it not work the way we intended it to, but it's not going to produce any error. And here's why. Because clock in was declared in the base class. So technically it works. Technically it is working just fine. It's just not doing anything because it's an empty function. It's an empty method. Now I could have some protections. Like I could take off the void return here. And here we're starting to get errors like, hey, I'm not returning a string. And so TypeScript is yelling at me, which is exactly what it should do. The only reason I have void in there is to make sure I'm not having a bunch of errors when trying to present things. So that's not distracting. So Liskov says a subclass must be a substitution for its parent class. This is the kind of scenario why. So the better approach, of course, would be, I'm gonna go ahead and comment this stuff out. And uncomment down here. So this would be the proper way to implement that, right? Here, the base class has the clock in functionality declared. And here I'm using polymorphism and I'm saying, oh, I'm going to go ahead and change to say host clocked in. That way, when I loop through and hit clock in, doesn't matter what kind of employee it is. Remember, it can be really one of 4 different types because the generic says restaurant employee. Well, because these 3 subclasses inherited from restaurant employee, all 3 of these count as a possible thing to put into this array. And then the other thing that is guaranteed, or that could be guaranteed, is if I, for some reason, created the restaurant employee directly. There's a way to protect ourselves against that. I'll get to that in a second. But because I used this generic and said, hey, I have an array of generic restaurant employees, I'm guaranteed that clock in functionality. And then this satisfies Liskov because Liskov says any one of these subclasses should be able to do what the parent class does. And I can achieve that through polymorphism. Specifically overriding functionality. That's Liskov. Mostly I just like the name. I just like to say Liskov. There's a good book out there. Robert Martin wrote it. And I think it's like Clean Architecture. And he tells the story of Liskov and what she contributed to the programming world. It's kind of an interesting little chapter. So recommend that book. Okay, let's go to I. I is the interface segregation principle. And it says a client, not literally like a client server, but a client being like a function or a method or a class that is using a piece of code from elsewhere. A client should not be forced to depend upon interfaces and methods they do not use. So I have an error on here and I can't really avoid it. That's what this example is all about. So this is why I love TypeScript, is because it produces errors. So if you're not familiar with interfaces, let me explain them really quick, because I'm using interface similar to the way that I was kind of using this, this restaurant employee back here. Here I was making a forward declaration with this class and saying there's no implementation, although there should be. But here I'm declaring that there's a clock in and a clock out piece functionality in the form of methods. I could also use an interface to achieve this. I could also use an abstract class to achieve this. But here what we're saying is the interface says, if you implement me, which is kind of like inheritance, and I'll get that in a second. If you implement me, the thing that you implemented, meaning if the class implements this interface, it has to follow the contract. As if you implemented this interface, you have to implement these pieces of functionality. And you're like, Scott, why would you want to do that? Well, I'm going to go back to this example down here, right? The reason why we want to do that is because that way we have guarantees. When we do things like go through arrays of different types of employees, we can guarantee through contract what method they actually have. So here I have I employee, and typically the prefix for interfaces is always I. So this is like saying, here's the contract for any employee that I create. It's the I employee. They can report hours, they can calculate pay, and they can terminate an employee. So all employees are able to do that. So I go to create my HR manager. I'm like super happy because, yep, HR manager can report hours, they can calculate pay, and they can definitely terminate employees. And then we get over to compensation manager, which compensations like salaries and calculating pay and that kind of stuff. You're fired. Compensation manager can report hours and calculate pay, but they can't terminate employees, right? I mean, maybe a compensation manager is not the right word, but maybe compensation employee, if it works a little bit better. Like they should be able to report hours and calculate pay, but they can't fire anybody. So I say, okay, well, gosh, how do I want to solve that problem? And the answer is interface segregation. And this is like the classic case of this, right? Is that I want to make sure that the compensation employee implements functionality to report hours and calculate pay. And by the way, if you're getting hung up on this, my apologies. Let me just go ahead and blow this out quick. Here we would return a number of hours. Here I would math and then return pay. So when I abbreviate these functions, like implementation, what's inside the brackets doesn't really matter. It has less to do with that than it does the idea behind it. So here what I'm saying is that we have this problem where I want to have a contract that ensures that the compensation manager implements these two pieces of functionality, but I got to figure out what to do with this terminate employee. So I'm kind of stuck. So the answer is interface segregation. And so interface segregation looks like this. Is that we start to split apart and we say, oh, well, I don't want you to like, I want to basically have multiple interfaces. It's like interface segregation is like giving the developer permission to implement multiple interfaces, which I think when developers learn about interfaces, they feel like they have to implement everything. It's like get it all into one interface and you don't have to, you can break them apart. So this is going to go back to those guarantees of functionality, right? If I use the iManager interface, I am guaranteed to be able to terminate an employee, or this HR manager can terminate employee because I signed the contract that I'm going to implement this interface. I'm guaranteed this piece of functionality and any other pieces of functionality that are inside of these curly braces. So if I made an array of HR managers, so if I said const HR managers, and I said is an array of generic HR manager, and I'm just like abbreviating here, I'm guaranteed that this array can terminate employees. Okay, then the compensation manager signs the same contract that the HR manager did in that they can get all the functionality of the compensation manager. So compensation manager guarantees that this class has the ability to report hours and calculate pay. And so then I'd implement those specific features there. But because I didn't sign or implement the iManager contract, there's no guarantee that this compensation manager can terminate employees. So in the way that interfaces work is that typically you write the interface first. And then what you do is you go ahead and say, okay, well, I'm going to, let's go actually rebuild this HR manager. We'll call this compensation employee. And so I'm building this out. And I'm saying, gosh, this person's going to have to be able to calculate pay and report hours. Is there a way that I can make sure that I do that? And when I'm coding, I can say implements, and I say compensation manager, and then automatically it freaks out at me. And you're like, why does it freak out at you? Because it's telling me that I signed the compensation manager contract, but failed to implement the report hours and calculate pay. So it's telling me, I'm like pointing at the screen, like you can see what I'm pointing at. I can't lift my mouse because I can't. Okay, here we go. It's saying report hours and calculate pay still need to be implemented in order for this thing to stop yelling at me. So I can just go ahead and be like report hours and calculate pay. And then it stops yelling hypothetically, but I have to write functions correctly. There we go. So then it stops yelling. I've implemented, it doesn't do anything, but it's there. So recap, interface segregation principle says, don't jam all your things into one interface, split your interfaces apart. It's okay. And then you can do multiple implementations if that's what you need to do, what guarantees you need. So going back to this idea of what guarantees does this by me? Well, if I have an array, so we say const HR managers or HR employees, and this is going to equal an array, I can guarantee that everyone inside of this, or sorry, what am I doing? Const HR employees. I don't know what the right way to do this is. We say array, and then we say the generic, and then I can point to, and this is what the D in S.O.L.I.D is gonna be all about, is I can point to not a class, but an interface instead. So I can say, you know what? Let's go and basically make an array of objects that have this implementation inside of it, and then it guarantees that all HR employees, no matter who they are or where they are on the array, they can calculates pay. Doesn't matter which version of the compensation manager they are. They can be HR manager or compensation employee. I'm guaranteed that piece of functionality through contract. Okay, let's get to D, and then I will open up to questions. So D is the dependency inversion principle. And this is the abstraction should not depend on the details. The details should depend on the abstractions. So I have some bad examples and I have a good example. So this is kind of the setup here, right? So I have a base controller. It's just a class. It literally doesn't have anything in it. I have an interface, literally doesn't have anything in it. And then I have a class. It's a service that implements this interface. This will become an important mechanic here in a second, but just another class. So two classes in an interface. Then I've created another class. And so I say, okay, create user controller, and the extends base controller, which remember does nothing. That's not the point. But here we're setting up a private property called email service. And so here I have the mailgun service, which is like a third party, like send people mail. And so here I'm hooking into the service that's going to email people. And I say, okay, I'm going to go ahead and create this user controller is going to have this email service as one of its properties. And so typical, right? Property, I say, okay, constructor. We're going to pass in an email service that is typed to the email mailgun service. And then I'm going to save that onto the instance, or save this onto, the instance of this new user controller. This is bad. And the reason why is because we are locking ourselves down to a particular, what we call a concrete class. So I'm pointing to saying email service has to be mailgun service. Like that, if I create a user controller, it has to be a mailgun service. The problem with this is, the reason why this is such a pain in the ass is because if all of a sudden my clients come, or my executives come and they say, you know what, Scott, mailgun's costing us a small fortune and we want to switch over to MailChimp. So I go and change, I create this new service based off of, I maybe take the mailgun class and I create the MailChimp service. I have to go into these controllers and I need to make these modifications. And so I need to go, basically the work that I did says, oh, I need to go change this user controller class to not just the mail service. I have to change both. I have to do two things instead of just one. So another bad example, and then I'll get to the good example, and we'll compare them. I just hate this in general. So here we are instantiating, like we're saying new mailgun service, and then we're not even really doing a good job marrying. Like you'd have to create more, like you'd have to, this is just gross. I see this a lot. So here, same idea, new mailgun service, or as a property on email service. We set that equal to new mailgun service, and we've accepted this as an argument, but we really haven't done much. So this is just another bad example. So before I show you the good, let's go back to the bad for just a second. I just want to point out one thing. This class, this property that we want on it is just email service. It's just like we want this controller to eventually be able to hook into an email service and say, I want to send emails. And that's the idea behind it, because like eventually the implementation is going to be like, something like mail user, right? I don't know, whatever. And so we say this dot email service, email user, and hello, right? Something, I don't know, I'm making this stuff up. So we pretend the email service as an email user method that reaches into Mailgun or MailChimp and sends the message hello. Like mail user doesn't care about Mailgun, doesn't care about MailChimp. Really, like this whole line does not even care about MailChimp or Mailgun. It shouldn't. Like that's not the point, right? Going back to the S and S.O.L.I.D, like single responsibility, like this shouldn't care about the implementation of email. We just want to go ahead and email the person. So the good looks like this. Let's go ahead and close up the bad. And here we go. We have completely abstracted away Mailgun. We abstracted away MailChimp. Doesn't matter, because what we said is we're pointing to not a specific implementation. We're pointing to an abstraction. So once again, this is all about what makes interfaces so damn powerful, and abstract classes so damn powerful, is I've effectively completely decoupled the dependency of that Mailgun service out of this controller. And I did that because how I achieved that is I said, well, Mailgun service implements the iEmail service, which is an interface that I can create contracts for. So by Mailgun service implementing the email service, I could say things like send mail. And so here, Mailgun service, this class has to implement this send mail functionality. So we'd say send mail, and that would look something like, whatever we want here, whatever we want to send the email. But what's cool is that I could take this and I could say MailChimp. And because both of these things implement the iEmail service, we've signed that interface contract that says and promises that we have the ability to send email from this class. I've guaranteed that both these classes have the send mail functionality. So down here, when I get to my email service and I say email customer, I can say this.email service .send mail. And it does not care which version of it is, right? It doesn't care at all. This doesn't care if it's Mailgun. It doesn't care if it's MailChimp. It doesn't matter, because both have signed the iEmail service contract that guarantees me this piece of functionality. So my boss comes and says, hey, we're getting off Mailgun, we're going to MailChimp. That's the point, Mary, is it shouldn't matter. It shouldn't. Mary asks, how do you know which one is being used? It actually shouldn't matter at all. But that would depend on when we instantiate it and all that kind of stuff. So basically the point is that I might need to change the service, right? Because I have to write a new service because I'm hooking into a new provider. I might need to change the instantiation point. So when we go to create this, right, we say const new something equals new create customer user controller. And we need to provide one of the two email services. So it could be the Mailgun or it could be the MailChimp. But the point is that I'll never, ever have to change the class that implements it because it has signed those interface contracts. Pretty damn good. And Peyton brings up another good point, is that there's another massive reason why we do these kinds of abstractions, is because writing tests for things like this is a lot easier than when things have very specific implementations. So I don't want to necessarily hammer in on that because we're kind of getting into time. I definitely want to stick around for questions. But the idea of S.O.L.I.D as a whole, and this is why it's so damn hard, I feel like, early career to look at some of the really well-architected code. I know I got frustrated. It's like, what the hell is going on? Why are we doing this? Well, the answer is modularization, like scalability, the ability to not redo a bunch of work if new things come in. So there's just a lot of really good reasons. I have some additional resources. I found a really cool article on, it looks like it's a series of articles on S.O.L.I.D principles implemented in React front ends. And I'll share that in the Slack channel. If you're not hooked up with the Slack channel, feel free to, I don't know, Rachel, if you're there, if you want to drop it in. Otherwise, I can, no, you rock. Join the Slack channel. I'll share the resources there that way you can check out solid implementations in React. But yeah, I want to get to Mary's question here. I know you can't tell from the controller, but how do you tell across the app which is used? Or I guess you said it in that new statement you typed earlier. Yep. So if you like ultimately need to figure out like where and how and when it's happening, you have to look and see. I'd probably do a search on, I would search this. I'd do Control-Shift-F, and I would search new, and then I'd probably go like that, and then find all the instances of anywhere I do this to figure out where did I instantiate controller, create user controller, and then I can see what specific email services is hooked up in there. I'm super lazy, like, or sorry, I'm a super efficient programmer. So big topic tonight. I wish I had like 18 more hours to cover it. It's a super cool topic. I definitely, the resources I'm going to point you to tonight, one's going to be an article on solid React implementations. The next article, or next repo I'm going to share with you is one of my mentors. I talk about this guy a lot. His name is Robert Savian. He was one of my mentors very early in my career. I'm so thankful for him. He berates me in a very loving way, and I love that dude to death. He is at a company called Parallax. He is the lead UI engineer for them. So very, very front-end heavy guy. And his architectures that he creates for like React, his jam, and he loves React. He loves MobX, which is like another client-side state abstraction layer instead of Redux. And he loves Next too. So I'm going to share his GitHub repo. Follow him, star him. He also has Medium articles too that explains all of his stuff. Yeah, I got paid and sold on him too. But I'll share his stuff too. And there's one architecture I'm going to share with you in there. It's his React Redux one, and it is some next level abstraction, and it is freakishly brilliant. And I would take some time to study it and look into it and figure out how he's doing things, because it enforces solid in some pretty cool ways. But I'll tell you, when you implement it and you get further down career, you got more people working on your projects, you need to scale it. You need to come back to code a year or two after you wrote it. If you have a good kind of architecture paradigm, a good set of principles, it becomes a lot easier to maintain and upgrade. That's it. That's the presentation. That's almost the hour. Yeah, I'll post these examples somewhere. Mary, are you in the Slack channel? You should just join. Come hang with us, Mary. Yeah. Sorry, I know Mary too. Mary and I worked together at my last gig. If you have questions, feel free to ask them. Otherwise, thank you so much for coming. We are rounding out the year. We have data engineering next month. So that is a whole other crazy topic. So we'll talk about things like Apache Kafka. We'll talk about the architecture of why data engineering is becoming more and more prevalent. It is definitely a good thing to have awareness around as you are continuing your web development career. You might not touch it, but you definitely want to be aware of what's going on with it. So thank you so much. Feel free to ask additional questions. I will hang out for a couple more minutes, but have a great night, and I'll see you in December.